Good morning, everybody. So today we are starting our last kind of official chapter. Basically, what we're going to do is we're going to take everything we did with the unit circle and apply it to the graphs of these 6 trig functions. And then we are done. You are almost there. So yay. Hopefully, if you're still struggling with the unit circle, definitely stop by for office hours so I can help because you're going to need to use those concepts for this chapter, okay? All right, first thing I want you guys to do is to pause the video and try this warm-up, and then when you're ready to see the answers, go ahead and unpause. All right, draw a quick sketch of the parent functions for each of the types of equations listed below. So parent function of a linear looks like this, quadratic, exponential. Technically, you could do exponential a slightly different way if you wanted to, but that's typically like 2 to the x, right? Looks like that. Absolute value is a v. A logarithm has an asymptote like this, so it looks a lot like exponential. So notice how I included the asymptotes in both. That's really important to keep in mind, otherwise they can tend to look very similar. Rationals tend to have 2 asymptotes and kind of look like that. Square root, something like this. Cubic function has that weird looking S kind of thing happening. And then, oh, whoops, that's cubed root. Hang on. I messed that up. Okay. So cubed root is the one that looks like this, excuse me, and then a cubic function looks like that. There we go. Sorry about that. All right, so what we're going to do is we're going to talk about the parent functions for the trig functions. So what's going to happen is we're going to learn 6 brand new parent functions: sine of theta, cosine of theta, so on and so forth, for all 6 of our trig functions. Then the next step, and one of the last things we're going to do before the end of the year, is how to take those functions and do those same movements, right? Left and right but backwards, up and down but normal, and then we will be done with the school year. So almost there, yay. All right, so what I want you to do is you should see attached your homework assignment, the homework number 1. So what we're going to do today is I want to go through the first 3. So I'm going to do the first one with you, kind of talking you through it. Your homework assignment is then to complete graphs number 2 and graphs number 3 from homework number 1 and check your answers using this video or using the key that I provide. Then tomorrow I'm going to make a different video for the last 3 trig functions and we'll do the same thing. So we're kind of splitting it up into 2 days so it's not too much work all at once for you guys. All right, so hopefully if you're able to print it off, awesome. If you can't, if you want to just draw a sketch of this on a piece of paper, I know it's not going to be perfect. Just do the best that you can, and I totally get it, okay? I am going to ask that when you're done with the 6 trig functions graphs, you are going to take a picture of it, so make sure, just like you guys did with the unit circle, you guys did great. Those of you that were able to print it off, awesome. If you weren't able to print it, you guys did a really good job drawing a circle as best you could, still color coding. I really appreciated that. It was really easy to see, and you can tell you guys did a good job. All right, so sine of theta. Anytime we started this year trying to figure out a parent function, I would say make a table, figure it out. What does the shape look like, right? We're going to do the same thing with sine of theta, okay? Where theta is like your x value and y is still your y value. So let's say I plug in 0. Basically what I'm finding is what is sine of 0 degrees or 0 radians. So I have my unit circle just off to the side. I know you can't see that because it's a video, but so I'm looking at sine of 0 degrees or 0 radians. And if I do what we've been doing, practicing with our unit circle, that is equal to 0. So I know 0, 0 is a point. So here's what's a little different. Notice my x values are a little bit different. They're in radians. And actually, if you notice, those radians, that first one, pi over 2 is 90 degrees, pi is 180, 3 pi over 2 is 270, and so on. There is a purpose to that, going up by 90 degrees. It's called polar coordinates, or it's similar to that anyways. It's not exactly polar coordinates, but there is a reason for that, and I'll show you in a second. So let's try plugging in pi over 2 radians. So again, off to the side, I have my unit circle in front of me. So if I find sine of pi over 2, that should be equal to 1. So at pi over 2, this dot is at 1. If I find sine of pi, that is equal to 0. Sine of 3 pi over 2 is equal to -1. So that's down here. And then sine of 2 pi again is equal to 0. Now, you might not be able to, when you go to find these points, you guys, you alone might not be able to figure out what it looks like. Like right now, you might think it looks like straight lines, like a V, like maybe something like this, okay? Well, that's not the case. And so that's where, if you need to, if you can at least get the points on your homework assignment, then you can use either this video or the answer key to help you get the rest of the shape or like the missing pieces, okay? Basically what this is doing is it's making what's called a sine curve. So I think you can kind of guess what's going to happen the rest of the way, right? It's just going to keep repeating. So if I use my unit circle and I find sine of negative pi over 2, that's going to be equal to -1. And so you'll notice it starts to kind of repeat the cycle there, okay? So here's what this is called. There's a couple things you're going to label on your homework assignment that you're going to see on your answer key. The first thing is the period. What a period of a function is and what it refers to is when is like a full cycle of that function has been accomplished. So usually what we do is we start a period right at the y-axis and we say, okay, when does it get, like, does it start back over again? So if you'll notice, if I follow this trend, it starts back over again right here at 2 pi. So the period for sine of theta is 2 pi, meaning it takes from 0 to 2 pi to make one full kind of transition, and then it'll start doing that same shape over again. The next thing I'm going to ask you to do is find the domain and range. So in this case, the domain is just negative infinity to infinity, right? Just keeps going forever and ever and always. And the range in this case is from -1 to +1. Okay, and it just keeps repeating, so that's called a sine curve. So here is your job for the rest of today. I want you to, so let me just make sure I've got everything. Yeah. I want you to go through and do now question number 2, which is cosine of theta, and question number 3, which is tangent of theta. Okay, do those on your homework assignment using the same idea. Find tangent of 0 degrees, find tangent of pi over 2 degrees, find tangent of negative pi over 2 degrees, and get as many points as you can on the graph. Then check your answers by figuring out what's the period, what's the domain and range, and kind of getting that general shape of what it looks like. So right now, pause the video, try questions 2 and 3 on your homework assignment now that we all did number 1 together. When you are ready to see the answers, unpause this video, and then I will walk you through some of the extra details of questions 2 and 3. All right, so here's question number 2, cosine of theta. Same thing, make a table. What does it look like? Cosine of theta ends up looking a lot like sine of theta. In fact, the only difference is cosine of 0 radians is 1 versus sine of 0 radians was 0. So there was a slight difference there. But you'll notice that if I start at the y-axis, my period is still 2 pi because it takes from 0 radians to 2 pi radians to make that full complete cycle of the graph. The domain is still negative infinity, infinity, and the range is still from -1 to 1. All right, let's look at the answer for number 3, tangent. The toughest part about this one, and I gave you a hint, is what is tangent of theta equal to for these particular spots, okay? So for example, tangent of theta, when it's equal to 0, remember tangent is the same thing as sine over cosine. So if I'm finding tangent of 0 degrees or 0 radians, sine in that case is 0, and cosine is 1. So tangent of 0 is equal to 0, right? But then, if I go to find tangent of pi is going to be sine over cosine. So tangent of pi is equal to 0, right? And so notice how that pattern is kind of occurring. And then it's like, okay, but what if I wanted to find tangent of pi over 2, for example? Well, tangent of pi over 2 is sine over cosine. Well, 1 divided by 0 is undefined. So it's like, okay, well, if it's undefined, what does that mean when I go to actually graph it? Undefined reminds me of an asymptote. So at pi over 2, there is an asymptote right here. Same thing happens at negative pi over 2. And so all you really have on your picture, you guys, is you probably have something that looks like this. And you're like, okay, what in the world am I supposed to do with that? I have a bunch of dots and a bunch of asymptotes. Like, how am I supposed to know what that does? So let me fill in the gap for you. This is what I'm looking for. Basically, what it does is if it's truly an asymptote, it approaches, let me get a new color here. It gets closer and closer to that asymptote, gets closer and closer to that asymptote. And it almost kind of looks like a cubic function that repeats over and over and over again. Okay, notice how if this is my starting point, the period is, okay, when does the graph repeat again? And it repeats again at pi, which is why tangent of theta has a period of just pi, not 2 pi. It has a much shorter time frame on the x-axis for it to start repeating. The domain is negative infinity to infinity. Now, technically, though, notice how I have this little exception here. This is really goofy, and if you're not going to pre-calc, really, you don't have to spend too much time with this. It's okay. The main idea for this is that basically tells you all the numbers that don't work. Otherwise, this graph keeps repeating infinitely to the right and infinitely to the left. So how am I supposed to say, oh, well, it's negative infinity to infinity, except for this line and this one and this one and this one, right? It's kind of hard to do that. So what we do is we say, okay, well, pi plus pi over 2 is basically where those asymptotes occur. This is not a big deal, you guys. If we were in class, I would spend more time with it. Moving forward in this class, I'm not going to spend too much time on it right now. You don't even need it on your homework assignment. Just make sure you have the period and the domain and range and all those data points fully on there. So let me erase this one more time so you can see it all without the weird markings I've got going on. That's what your graph should look like right there, okay? All right, you do not need to submit homework number 1 until tomorrow because I want you to do all 6 of them. We'll start our video tomorrow with questions 4, 5, and 6, and then you'll be able to submit your homework assignment, okay? Again, stop by for office hours if you need help.